In this video, I will walk you through free response question number 3 from the 2004 AP Calculus exam. This is a calculator active problem. Problem number 3 is primarily about the relationship between position, velocity, and acceleration. A particle moves along the y-axis so that its velocity at time greater than or equal to 0 is given by this equation. At time t equals 0, the particle is at y equals -1. Find the acceleration of the particle at time t equals 2. Since this is a calculator active problem, let's start by typing this equation into the calculator. When I do a position, velocity, acceleration problem on the calculator, I always like to put the position function in y1 and the velocity function in y2 and the acceleration function in y3. That way I don't have to try to remember which one is which because I always do it the same way. So we're typing in a velocity function, so I'm going to put it in y2. And it was it was 1 minus the inverse tangent, so second tangent, and then it was e to the x power. So I'm going to do second, so I've got my e to the x, and I'll just go ahead and put the x in there. I think on the actual AP exam it was a t, but we're just going to stick with x. And let's close that off. So we've typed it in. For part A, we need to find the acceleration of the particle at time t equals 2. So we need to find acceleration at 2, but we know that acceleration is the derivative of velocity. So we need to find v prime at 2. The calculator will do this beautifully. So let's quit to a blank screen. If you want to evaluate the derivative of a function, you can use the math functions, and function number 8 is the derivative. So I'm just going to press 8. So I'm going to differentiate with respect to x because that is my variable. Now I want to use the function that I typed into y2. Here's how you get y2 right here without having to type the whole function in. Hit the vars button, and we want yvars, so just go over there and choose function. And so here are the functions that we could type in. We typed the velocity into y2, so I'm going to choose that and hit enter. So this is the derivative of the velocity, and I want to evaluate this at x equals 2. So here it is. Kabam! This is it. So we're going to use 3 decimal places on the AP exam. So I'm going to call this negative 0.133, but the AP exam would also accept negative 0.132. You can truncate or round properly. But I like to round, so I'm going to put negative 0.133. And that's the answer to part A. Part B, is the speed of the particle increasing or decreasing at time t equals 2? Give a reason for your answer. Here are some notes that you need to understand this problem. The speed is increasing if the velocity and acceleration both have the same sign. For example, if the velocity is positive and the acceleration is positive, then the speed is increasing. On the other hand, if the velocity is negative and the acceleration is also negative, again, the speed will be increasing. We already know that the acceleration is negative. So let's go ahead and find the velocity at time t equals 2, so we can see if they're both negative. Once you have typed a function into the calculator, an easy way to evaluate the function at a particular value of x or t is to use the table feature. So I will hit second table, and now I can just type in the value at which I would like to evaluate. So I want t equals 2, which we're using x, so x equals 2. And there it is. The value of function 2, which was the velocity, is negative 0.436. By the way, if I needed more decimals, I could just highlight it and here's a bunch of them. But 3 decimals is perfect for the AP exam. So negative 0.436. So I'm going to say that V at 2 is equal to, wait, I already forgot what it said, negative 0.436. Negative 0.436. Notice that these are both negative, so therefore the speed is increasing. For my explanation, I am going to list the velocity at 2 and the acceleration at 2 sort of side by side, and I'm adding this little statement on the end indicating that each one is less than 0. In other words, the velocity is negative at time t equals 2, and the acceleration is negative as well. And now I can make my summary statement. The speed of the particle is increasing at t equals 2 because the velocity at 2 is negative and the acceleration at 2 is also negative. Part C. Find the time t greater than or equal to 0 at which the particle reaches its highest point. Justify your answer. When we talk about the highest point, we are talking about the absolute maximum of the position. When we look for the absolute max, normally we use a candidates test. However, we can't do a candidates test this time because we don't have a closed interval. In order to do a candidates test, we need endpoints like 0 and 5, which we don't have. We can find the absolute max without a candidates test as long as the position function turns out to only have one critical point. If a function only has one critical point, then a relative max will also be the absolute max. This makes sense because if we have a relative max like this, and let's say we don't exactly know what happens outside of this small window. However, if this is the only critical point, then there's no way that the function will bend back around and end up higher than this point. Because if the function did bend back around, guess what? We would have another critical point. If there are no other critical points, there are no other bends in the graph. So a relative max will definitely be the absolute max as well. To find the critical points of the position function, we need to find where the derivative equals 0. In other words, we need to find where the velocity function is equal to 0. We have the velocity function typed in as y2. Let's take a look at the graph and see if we can find where the velocity is equal to 0. So this velocity graph does seem to have only one critical value. Let's find what that is. So hit second trace, and we can use the 0 feature, so option 2. When it says left bound, slide over a little bit to the left of where the intercept is and hit enter. And then it says right bound, slide to the right of the intersection point and hit enter. And then when it says guess, just go back close to the intersection point and hit enter. So there it is, 0.443. So we just saw that t equals 0.443 is the only critical value of the position function. If this turns out to be the location of a relative max, it will also be the location of the absolute max. So how can we tell if this critical point is the location of a relative max, a relative min, or neither? Our favorite tool for identifying the location of a relative max or a relative min is the first derivative test. So let's make a sign chart of velocity and see what happens at the critical value. From the graph, we can see that velocity was positive on the left and negative on the right as it goes from above the x-axis to below the x-axis. According to the first derivative test, The position function has a relative max at t equals 0.443 because the velocity changes from positive to negative. Since t equals 0.443 is the only critical value, this relative max is also the absolute max. Let me emphasize one more time that usually when they ask us to find the absolute max or the absolute min, we use a candidate's test. But that only works when they give you an interval with endpoints. If they don't give you an interval with endpoints, check to see if there is only one critical value. If so, any relative max will automatically be the absolute max, and any relative min is also the absolute min. Part D. Find the position of the particle at time t equals 2. Is the particle moving toward the origin or away from the origin at time t equals 2? Justify your answer. Here are some notes illustrating the strategy that I'm going to use. The position at time t equals 2 is going to equal the position at time t equals 0 plus the change in position from time t equals 0 to time t equals 2. For the position at time t equals 2, I'm going to write y at 2. But what about the position at time t equals 0? In the setup of the problem, we were told that at time t equals 0, the particle is at y equals -1. So we know the position at time t equals 0 is -1. Now here comes the trickier part. Here's something that you need to memorize. The change in the position function is the integral of the velocity function. You need to memorize this. So one more time, the change in position is always going to be the integral of the velocity function. If I want the change in position from time t equals 0 to t equals 2, then I will integrate the velocity function from 0 to 2. And we can just put this in our calculator in the following way. Go to a clear screen on your calculator. Let's start by typing in -1 plus. Now we need the integral. So hit the math button, and the integral is option number 9. So I'm just going to type 9. We wanted the integral from 0 to 2. So I'm going to type 0 and then 2. We are integrating the velocity function. Remember, we have the velocity function sitting at y2. So you will use the vars button and go to yvars and choose function, and here's y2. This is the velocity function. So we are integrating the velocity function, and we are using the variable x, and this should be it. So -1.361. I'm rounding up. You could put -1.360, and that would also get full credit on the AP exam. So we have now answered the first part of the question. Find the position of the particle at time t equals 2. Y at 2 is -1.361. How about the rest of the question? Is the particle moving toward the origin or away from the origin at time t equals 2? I'm going to give you some notes on this in a moment, but first I want you to look back at the notes I gave you in part B because they are analogous. Remember, I said that the speed was increasing if the velocity and acceleration have the same sign. I can say something similar about the position function and the velocity function. Add this to your notes. A particle is moving away from the origin if the position function and the velocity function have the same sign. If they have different signs, then the particle is moving towards the origin. We already know that the position function at time t equals 2 is negative. So we need to evaluate the velocity at 2 and see if it has the same sign. Actually, I just remembered that we already evaluated the velocity at time t equals 2 back in part B. And here it is, and it was negative. So here is our summary statement. the particle is moving away from the origin at time t equals 2 because the position at 2 and the velocity at 2 are both negative.